Today we're going to talk about chapter 3 section 1. The title of the chapter 3 is Atoms, the Building Blocks of Matter. Section 1, the atom from philosophical idea to scientific theory. Let's start. Democritus, 400 BC, he was a Greek philosopher, Democritus. He developed a theory that if you continuously cut an object, you eventually end up with a particle that could not be cut. He called the particle an atom. Yani he said, if there is any particle, this marker, if you cut it down continuously into smaller particles, he said, at the end, you get a particle, you can't cut it down anymore. He called this particle what? An atom. Okay? He said that all matters, they are made of a small particle, and he called it atom. Basha? So, from the Greek word, the atom means indivisible. Okay? Atom means indivisible. So, and indivisible means what? Not able to be divided. Okay? So here what you need to know, the first person that talked about what's matter made of was the Democritus, and 400 BC means before Christ. And here this is his idea. He said eventually if you cut an object, you end a particle, you can't cut down anymore. Okay, so another philosopher, another ancient Greek philosopher, Aristotle. Aristotle, he said that all substance in nature, they're made of 4 elements, just 4 elements: earth, air, fire, and water. Okay? And today we know that he was wrong. The earth, the nature, is made of is made of 118 elements, right? But he said all substances are made of 4 elements. And he didn't think there is a limit to the division of matter. He didn't think that there is a small particle. And he said that all matter is continuous. There is no end for division of matter. Okay? And for 2,000 years, most people accepted Aristotle's views on the structure of matter. Imagine, for 2,000 years, most of the people in the world accepted what? Accepted his view on the structure of matter. Means all the people most of the people believed that all substance, all matter made of 4 elements: earth, air, fire, and water. Okay? This is here important you to know that Aristotle gave his idea and he didn't explain, he didn't prove it by experiments. So also Democritus said all matter is made of small particle, atom. Also he didn't prove. Aristotle also didn't prove about their idea. It was just an idea. Okay? Foundation atomic theory. Here, after these philosophers, science, they start studying about matter. Many scientists, they came and they talked about what matter made of. So almost all chemists in the late of 1700s accepted the modern definition of an element as a pure substance, as a substance that cannot be further broken down by ordinary chemical means. And also it was clear that elements combine to form compounds. Okay? All chemists in the late of 1700s, they accepted there are elements, and elements they cannot be further broken down by ordinary chemical means. So, and they knew that elements, they combine to form compounds. After that, in the 1790s, study of matter was developed. How? By focusing on what? Quantitative analysis about the amount of the elements. Okay, quantitative analysis of chemical reactions. And the investigators, they started accurately measure the mass of the elements. Okay, after that, scientists in 1700s, they started to measure the to measure the mass of the elements in the chemical reactions. After they studied about the masses and the quantitative analysis of chemical reactions, this led to discover several basic laws. Okay, sometimes we call them basic laws of chemistry or matter. The first one was law of conservation of mass, law of definite proportion, law of multiple proportion. Okay, let's start talking about each of these laws. The first one, law of conservation of mass. Law of conservation of mass says mass is neither created or destroyed during ordinary chemical reaction or physical change. Do you remember in chapter 1 we talked about chemical property, chemical change and physical changes, right? So in any chemical changes, in any physical changes, when two elements, they react with each other, see, the amount of the reactant must equal the amount of the product. Here, look at this question. We have 20 grams of A. A can be element, a substance, and or a compound. 20 grams of B, element. So at the end, we get 40 grams of AB. So the total amount, we have 20 plus 20 grams of A plus 20 grams of B equals what? 40 grams, right? 40 grams. This is the amount of the reactant. What about the amount of product? Is what? Is 40. So in this chemical reaction, matter has not created or destroyed. It's 41, okay? It's 41, we say matter is created. But there is a law says matter cannot be created or destroyed. If 39, you might say the matter, 1 gram of AB has what? Has destroyed. So cannot be destroyed. So the amount of the reactant, the total amount of the reactant must equal the total amount of the product. You know that we said the substances or before the arrow is called what? Reactant. And after the arrow, what we have is called product. Okay? So I think this law is easy. In a physical change, for example, you burn a paper, Basha. So at the end, this is a chemical change. At the end, you get an ash and carbon dioxide. Do you know that the amount of ash and the carbon dioxide must equal the mass of the paper before you burn it? Okay? So for physical change, you burn a glass of water. Okay? Sorry, you boil a glass of water. So when the water boils and changes to gas, the amount of gas particles or water vapor must equals what? The amount of liquid water before you boil. Okay? It cannot be create or destroy. Cannot be more than or less than the water. Also, this is a reaction. It is same if we have what? We have, let me erase it. This is for carbon and oxygen. Okay, we have carbon, if it has mass x, x can be a number. Oxygen, the symbol is O, mass y. So carbon has mass x, oxygen has mass y. When it produces carbon monoxide, so the mass of carbon monoxide equals the mass of carbon and oxygen, the reactants. So equals mass x plus mass y. Okay? When you decompose carbon monoxide compound, it has mass x and mass y. At the end, it will be mass of carbon and mass x and mass y. Okay, cannot be created or destroyed. The second law is law of definite proportion or composition. This law is easy. I think you learned in chapter 1, section 2, right? We talked about the difference between compounds and mixtures. We said compounds, they have fixed composition. Okay, let's talk about. It says a compound always contains the same elements and in exactly the same proportion by mass. Look at this picture. These are solid crystals, right? Each one of these, if you take a sample by mass, 39.34% is the mass of sodium, 60.66% is the mass of the chlorine. Okay, we have Na and Cl. Okay, NaCl. This is a compound. And a compound, NaCl, is always made of what? Made of sodium and chlorine. So how it produces when Na, solid sodium, react with chlorine gas, okay, it produces NaCl. Let's balance. Okay. So NaCl as a compound always is made of what? Sodium and chlorine. Look, sodium and chlorine cannot be produced or cannot be, when you say sodium chloride, cannot be something else. It's always made of sodium and chlorine, right? Okay, so it says in exactly the same proportions by mass. Okay, so it means by mass, if you take a crystal of salt and a sack of salt, always by mass, okay, the ratio will be in exactly the same proportion by mass. So it will be 34% will be the mass of what? Mass of sodium. And for chlorine, 60.60 what? 66%. Okay, This is the law. Compounds, they have fixed composition. So they are always made of same elements and also in exactly the same proportion by mass. We said if we have, for example, for water, do you remember we talked about H2O is the composition of water, right? Water is made of H2O molecules. So water is always made of hydrogen and oxygen, always contains two hydrogen and one oxygen, they have bonded together. Also we said, you remember we said by mass, how we measure the mass? In this chapter, inshallah, chapter 3, section 3, we're going to talk about how can we measure the mass of the atoms. By mass, hydrogen, we know it's lighter than the oxygen. So there are two oxygen, but still lighter than oxygen, one oxygen atom. So by mass, 11.2% is the mass of hydrogen and mass of 88.8 is the mass of oxygen. Doesn't change. It's a law. Okay? By mass, if you take, this is one molecule of water. If you have a glass of water, it's same. By mass, a glass of water, 11.2% is mass of hydrogen and 88.8 is the mass of oxygen. So compounds are made of same elements in exactly the same proportion by mass. Okay, that's enough. Law of multiple proportion. Law of multiple proportion. Do you know that some compounds, they are made of same elements? Okay, what happens? If two or more compounds are formed of the same two elements, then the ratio of the masses of the second element combined with a certain mass of first element is always in a ratio of small whole numbers. Look at a question, an example. We have carbon monoxide and carbon dioxide. These are two different compounds, but they are made of same elements. Carbon monoxide is made of carbon and oxygen. Carbon dioxide is it's also made of carbon and oxygen. What's the difference between them? Here we have one oxygen. Here there are two oxygens. So if we talk about the definition, it says if two or more compounds formed of the same two elements, Basha, then the ratio of the masses, ratio by mass, of the second element or the elements will be in small whole numbers. You know, whole numbers 1, 2, 3, 4 must be not decimal, 1.2, 1.3. So their ratio must be in small whole numbers. Okay, how we know that the ratio between oxygens in carbon monoxide and carbon dioxide are in small whole numbers? Look, guys, the carbons in mole, there are 12 grams of carbon in 1 mole. Okay? So we can say the mass of carbon is 12 grams. Okay, later we will talk about moles. And for carbon, in carbon dioxide is still 12. Mass of carbon doesn't change from a compound to other compounds. So here there are 16 grams of oxygen. You know, the mass of oxygen is 16 grams, okay, per mole. So what about if we increase the oxygen? So for 2 oxygens will be 32 grams, okay? So their amount, the ratio of the total mass will be 28 grams. Here will be 44 grams. So I want to know the ratio of the oxygens in these two compounds. For the carbon, so here is 12 gram. Here's 12 gram. Okay. So how I can get the ratio? You know, in both compounds are same, so both of them divided by 12. Let's simplify. Divided by 12, it equals what? Equals 1. Here is equals 1. So the ratio of carbon in carbon monoxide to the carbon dioxide is 1. 1 to. The ratio is what? 1 to 1. Okay. Let's get the ratio of the oxygens in these two compounds. Here is 16. Okay. Here is 16. Okay. 16. But I'm showing it in the reactant. So here 16 in the carbon dioxide, there are 32 grams. Okay, let's simplify. Both of these sides divided by 16. We choose the smallest one, right? It's 32 and 16. Which one is smaller? 16. Okay, 16 divided by 16 equals 1. 32 divided by 16 equals 2. So the ratio of oxygen between carbon monoxide to the carbon dioxide is 1 to 2. So do you know that their ratio is in small whole numbers, right? It's not 2.1, cannot be. Why it's like that? Because we say that atoms of elements, they combine in small whole numbers. You can't react one oxygen with 1.5 oxygen. Doesn't make sense. You want to say that half of the oxygen react with the one oxygen. Doesn't make sense. So it must be in small whole numbers. Okay. So you want to buy a ball. You go to a shop. You can't say, give me half ball. Doesn't make sense, right? So this is also for atoms are like that. Half of an atom doesn't react. So if there's 16 grams for one oxygen, so directly when you increase the oxygen, directly becomes 2. Cannot become 1.5 oxygen. Be 20 or less, or 25 must be 32. If for one oxygen is 16, for two oxygen must be 32. So the ratio of the oxygen is, here is one oxygen, here there are two oxygens. So the ratio by mass is what? It is 1 to 2. Okay, I hope you understood. So the mass of the carbon in this is same in the two molecules, right? Here we said, okay. But the mass of oxygen is in carbon dioxide is twice the mass of oxygen in carbon monoxide. Thus, the mass of oxygen in two compounds relative to a fixed mass of carbon are in ratio of small whole numbers 1 to 2. Okay. Another example, same example, between nitrogen monoxide and nitrogen dioxide. These two compounds are made of what? Same elements, and the ratio of the nitrogen here and the nitrogen dioxide, their ratio must be in small whole numbers. That's easy because we have one nitrogen here. Also, we have one nitrogen dioxide, so must be same. For the oxygen here is 16. We said if there are two oxygens, must be 32. So we want to know their ratio by mass. Both of these sides divide by 16. It's like the other example. This is going to be 2 equals 2, and here equals 1. So the ratio is what? Is 1 to 2. Okay, the ratio of oxygen between nitrogen monoxide to the nitrogen dioxide is 1 to 2. Okay. Here there are some questions related to the laws that we talked about. It says if 4 grams of element A react with 10 grams of element B, how many grams of A will react with 50 grams of B? So if there is A plus B react to produce a B compound. Okay, it says there are 4 grams of A. Basha, there are 4 grams of A. React with 10 grams of B. Basha, we are not talking about the product. We know that's going to be 14, right? 14 grams, but we don't need now. The question says, how many grams of A will react with 50 grams of B? So it says if we have 50 grams of B, so how many grams of A will react with 50 grams of B? So we know we have cross product. 4 times 50, what? 4 times 50, 200, divided by 10 is going to be 20, right? Okay, so this is cross product. You can do it. You learn in math. Okay, this in the question 2, it's same. Here is just going to be, there are 2 grams of A. This is going to be 2 grams. With 10 grams of B, here is going to be 10 grams. Then 12 grams of A will combine with how many grams of B? Here, now here there are 12 grams, is going to be X. Okay, and you can find in the same way is going to be 60 grams. The last one, which is different and it's related, actually the third one is related to the third law of multiple proportion. It says 3 grams of C, okay, 3 grams of C combine means this plus shows combine with 12 grams of D, Basha, 12 grams of D, 12 grams to what? To produce CD, Basha. Okay. Now it says how many grams of D are needed. Here there are, for C doesn't change, 3 grams. Okay, 3 grams plus the amount of D, we don't know, to produce CD2. Okay, here for 1D is 12 grams. It must produce 2D, right? So the D must be, you must what? Increase the amount of D in twice. So to produce 2D2, here is what? Is 12, right? 12 grams. Here for D2, it must be what? For 1D is 12. For D, 2D must be twice. It's going to be 24. So here in the reactant must be 24. Why we write D2? Because we have 24 grams of what? Of D. So the answer is what? 24 grams. Okay? So Dalton's atomic theory. Dalton's atomic theory, 1808. So Dalton came and said, it can explain the 3 basic laws. So he gave an explanation. He proposed an explanation for these 3 laws. Okay, Dalton, he was English man and he was school teacher. Okay, John Dalton. Okay, let's explain the postulates or the summary of the Dalton's atomic theory. Postulates of Dalton's atomic theory. You must memorize these, and we're going to talk about. Okay, all matter composed of small particles called atom. So you might say, teacher, Democritus said the same thing. Right, but Democritus didn't prove it. But Dalton came and proved, okay? He proved. Okay, he proved. Okay, so this is the first postulate point. Then he said atoms of same element are same in size, mass, other properties, while atoms of different element have different properties. Okay, what does it mean? He said that we have sodium atoms. Sodium element is made of sodium atoms, or hydrogen is made of hydrogen atoms. He said that all the atoms of the same element, they are same in size, mass, other properties. And he said atoms of different elements, they have different properties. Okay, later I'm going to explain that he was wrong at this point, because atoms of same element, they can have different masses. Okay, next slide I'm going to explain. The third one was atoms cannot be subdivided. He said atoms cannot be subdivided, created, or destroyed. He was right at these two, but actually he was wrong. Atoms, they can be subdivided. They can be divided into smaller particles: proton, electrons, neutrons. Proton, electron, and neutrons. The first one, atoms of different elements combine in small whole numbers ratios to form what? Chemical compounds. Okay? So we know that carbon reacts with oxygen to produce carbon monoxide, right? Here is 2, but when we balanced with 1/2, here is going to be 1. Okay, so here we have 1 carbon react with 1 oxygen. Cannot be 1 carbon react with 0.5 oxygen. Doesn't make sense. As we said, you can't say half of a ball. You can't buy a half of a ball. So 1 carbon cannot react with half of oxygen here, right? Okay. It's going to be carbon monoxide. He said in chemical reactions, atoms, they combine. Here carbon and oxygen, they combine to produce carbon monoxide. They separate. You know, we learned about separation of water. Water can be separated into oxygen and hydrogen. They are also rearranged. We have different compounds. They rearrange, or they swap their atoms, but they cannot be what? Create or destroyed. Okay? Modern atomic theory. We all know that modern atomic theory, this modern atomic theory, we have electron, neutrons, and this nucleus. In the nucleus, we have neutrons and protons. Electrons, they are moving around the nucleus, right? This is a modern atomic theory that today we know that. But if we compare it with the modern atomic theory, there are 2 mistakes, there are 2 failures in the Dalton's atomic theory. Let's talk about failures of Dalton's atomic theory. Dalton's atomic theory was good, but it failed at 2 points. First one, he stated that atoms, they are indivisible, but we know that, and also he said which cannot be divided. But according to the modern atomic theory, he was wrong. The correct one is atom is divisible into smaller particles: proton, neutron, electrons, right? This is modern atomic theory. We know that there are particles that are smaller than atom: electron, proton, neutrons. They are inside of the atom. He was wrong. Also, he was wrong, okay, that he said that atoms of an element have same mass. Atoms of same element, they can have different masses. Okay, this is the correction version. Isotopes. In chapter 2, we're going to talk about, in section 2, we're going to talk about, for example, isotopes of hydrogen. Isotopes of hydrogen, they are hydrogen atoms. They are atoms of hydrogen, but what? They have different number of neutrons. They have different masses or mass numbers. Look, which one is heavier? Tritium is heavier. They have different masses. Okay, so protium doesn't have neutron. They are same atom. It means they are atoms of hydrogen, but they are different in number of neutrons. So they have different masses. Okay. This is the section review. This is the first one. It says, describe the contribution of Democritus to the modern atomic theory, then show the contributions of Dalton. Here is what is important. Democritus suggested atoms as fundamental particles. He said that atoms, matter is made of small particles, which is atom. But Dalton proposed elements made of identical atoms based on careful experiments and observations. Dalton proved by experiments, proved that the matter is made of atom. But Democritus, he was just suggested. Okay, so here this second one, you can get it. Here is also about the comparison between or based on Dalton's atomic theory, the law of conservation of mass, law of definite proportion, and the law of multiple proportion. Okay, explain it. So it's written here. Inshallah, later on we will talk about chapter 3, section 2. Okay, thank you. Bye.